The Softphone component, coupled with the acoustic echo canceller, lets you use the Q-SYS Designer software for high-quality distance conferencing. This component allows Q-SYS to register to any Voice over Internet Protocol, or VoIP, including analog hybrids connected to a standard telephone line or a fully digital VoIP method running on your existing network. This feature is not dependent on hardware, but is implemented in the software within each core, therefore it comes at no cost. Furthermore, multiple Softphone components can be used simultaneously, making it simple to create multi-room systems within a single core. Your first step is to add a Softphone component to your design. You can do this by going to the Inventory panel, selecting the plus icon, select Streaming I/O, and then Softphone. You'll see this added to your inventory, and you'll notice that it has 3 components to it, which you should drag into the schematic. The Status Control component gives you control over the Softphone. The In component acts as an input and lets you route your incoming audio into your design, and the Out component represents the audio that you would like to send to the phone and to the outside world. To make things simple, let's connect these to our core. I have a microphone attached to this mic line card in our core, which we'll use to speak to our caller. I'll just wire this microphone to the Out component. I also have a loudspeaker attached to this line Out card, which we'll also drag into the schematic and connect to the In component. Now, for a conference room scenario, we'll need to use acoustic echo canceling. So let's drag an AEC component from the schematic library. Let's take a moment to look at the pins on the AEC component. There are 2 input pins and 1 output pin. The first input pin is labeled microphone, which is obviously the local microphone that the near-end caller is speaking into. If you're using multiple local microphones in your conference room, QSC highly recommends that each microphone has its own AEC channel, because the impulse response for each microphone will be different. If you are unable to provide each microphone its own dedicated AEC channel, you can sum the microphone signals with a mixer, but be aware that this may provide compromised results. The first output pin is labeled conference, which is the main output that you will be sending to your far-end caller. If you would like to apply any additional processing in this signal path, you must do so after the signal has been processed by the AEC components. Do not apply any processing between the local microphones and their input to the AEC. The second input pin is labeled reference. This should be a copy of the incoming telephone feed after all processing has been applied to it. You want the same signal sent to the reference pin that is being sent to your local loudspeakers, because the AEC is using this signal as a reference for the noise it will eliminate from your local microphones. If you mistakenly took this signal before your processing is applied, then your AEC isn't being given an accurate reference of what will be broadcast from your loudspeakers. A second output pin is available, labeled reinforcement. You can activate this pin in the AEC Properties panel by changing the Reinforcement output field to Yes. This pin is only used for large rooms, typically conference rooms or legislative facilities, where you would like the audio of the near end reinforced over your local PA system as well. This way, everyone in a very large room can hear both ends of the conversation. This signal will not include the local noise reduction or comfort noise processes that you learned about in the previous section. We have an excellent sample design available in the project files for this course that you can download that shows more examples of correct and incorrect ways of applying processing to the AEC component. So, back to our Softphone design. Let's apply this knowledge. I want to route our local microphones to the microphone pin of the AEC and then send the conference signal to our Softphone out. We'll also need to split the incoming Softphone signal to the reference pin of the AEC so that it knows what echoes to remove from the final audio. The next step is to properly configure the Softphone to work on your network, which is done in the administrator. I'll run this design to the core now, which lets me access the administrator icon here in the upper right-hand corner. Once a Softphone is part of your design, you'll see a navigation tab for Softphones here in the administrator. The panel has 2 columns, one that lists the Softphones in your inventory, and one that lists the audio codecs. You have to make sure you select the proper network here in the interface field. Your core has a LAN A and a LAN B connection, as well as an auxiliary A and, for larger cores, auxiliary B. Be sure to select the network that connects to the outside world. Double-click your Softphone and you can edit how your phone connects with VoIP. You'll need to input your username and proxy, select whether or not you would like to register with the proxy, and also input your authentication ID and password. You should be able to get all of this information from your IT technician or VoIP provider. And some VoIP providers will use your username as your authentication ID as well. Once your information is all input properly, hit OK and update settings, and then you can exit Administrator to test out your Softphone. If you double-click the status Softphone component, you'll get its control panel, which shockingly looks a lot like a phone. On the right, you can use the keypad to enter a number, or you can type it in the outgoing field, or delete a number with these buttons. The incoming field shows the activity of an incoming call. The DND, or Do Not Disturb button, will block incoming calls. You can hang up on an active call or press dial to launch your outgoing number. If you were born after 1985, you may be confused why we use the verb dial in reference to telephones rather than send or call, but don't worry, it all means the same thing. If your phone is either off hook or ringing, these lights here will illuminate. You can select your phone to automatically answer after a designated number of rings, and the status bar will give you critical information on what the Softphone is currently doing. So let's try it out. I'll input a number and hit dial, and I'll activate the hover monitor for my line outs card so that you can hear it through the PC sound card.
Hello.
Hey Patrick, it's Nate.
Hey Nate, what's going on?
Not much, just showing Softphone.
How exciting for everybody involved. Can I go now?
Okay. Now, we set up a pretty basic system, but let's take a look at a few other options you may want to incorporate. First, let me disconnect from the core so that we can change the design. Now, first of all, I would recommend pulling an automatic gain control into the incoming signal, as well as a parametric equalizer. These will help balance out quiet and loud talkers and generally smooth out the audio of your caller. Also, you may have noticed that when you receive an incoming call, your only notification is this red light in the Softphone's control panel. Now, personally, I'd like to hear it ring, so I'm going to pull in an audio player and we'll use that as a ringer. First, I'll go to my Softphone's control pins and activate the ring trigger pin, and I'll activate the audio player's play trigger pin. Then, if I connect these two, then when the phone rings, it will play an audio file like a short beep or a horn. On the other hand, maybe you'd like to play a longer audio file like as a ringtone. In this case, it won't do to just spam the play trigger over and over, so instead I'll open the ringing state control pin. When this state is positive, I want it to trigger the play trigger. When the state is negative, I want it to activate the stop trigger, or else it will keep playing during my phone call. To do that, I can grab a control function component, set its function to logic not, which basically says that when the Softphone is not ringing, then stop the audio player. There we go. Now, there are a lot of other things you could do to customize this Softphone to your own needs. For instance, let's look at this design, in which we've built ourselves a speed dial. This is just a container with some other components in it, and the dial string and connect buttons are wired to a bit of Lewis scripting. And here we've made a pop-up with text fields in it. We made these text fields just by pulling them from a custom controls component like this one. Now, I can label each of these speed dials, input a number for it, and then when I hit dial, it will automatically put that dial string into the Softphone and connect automatically. You can download this project file from our website to take a look at the scripting and maybe even use it in your own design. Then you could pull this pop-up into a UCI, such as a touchscreen or an iPhone, and make a call from there. Just imagine being able to make a call from your phone. All right, well, you get the point. Thanks for watching, and we'll see you next time.